Today we are going to discuss few more questions in series type. So you see what is that given question in this one? That is that cot inverse of 7 by 4 plus cot inverse of 19 by 4 plus cot inverse of 13 by 4 plus cot inverse of 67 by 4 plus and so on. Already, so we discussed the same kind of question in previous lectures. So now what is the difference of the previous question and this question? You see here you can write that cot inverse of 7 by 4 plus cot inverse of 19 by 4 plus cot inverse of 39 by 4 plus cot inverse of 67 by 4 plus and so on. Okay, and so on to infinitive. We know that one formula is that first basically I told you, other than tan inverse, any inverse trigonometric function is given, you should change into the tan inverse, because it will be very easy to find out the sum of the n terms or sum of the infinite terms of the series. So you know, first of all, cot inverse of x is equals to tan inverse of 1 by x. Okay, by using this formula, cot inverse of 7 by 4, you can write that a tan inverse of 4 by 7. Tan inverse of 4 by 7 plus tan inverse of 4 by 19. Tan inverse of 4 by 19 plus tan inverse of 4 by 39. Tan inverse of 4 by 39. Okay, plus tan inverse of 4 by 67. So now the same series 4 by 67 plus and so on, the same series already we did in the previous lecture. Now here how to find that general term? General term means so here you write that TR is equals to, this one will be tan inverse of, this value is the tan inverse of 4 by denominator 7, 19, 39, 67 and so on. So this general term you will be write that 4 into r square plus 3. So after that, how to do this one we discussed already in the last lecture. Divide the numerator and denominator with 4. Then it becomes that tan inverse of 1 by r square plus 3 by 4. 3 by 4 you can write that 1 minus 1 by 4. 3 by 4 you can write that 1 minus 1 by 4. So that is equals to tan inverse of this one is that 1 by 1 plus r square minus 1 by 4 you take as one term. Then you can write that r plus 1 by 2 into r minus 1 by 2. R minus 1 by 2 you can write it. So now after this one, so here the numerator 1 will be replaced with this value, that is equals to tan inverse of. So numerator should be right in terms of r plus 1 by 2 and r minus 1 by 2. So now you have to write that r plus 1 by 2 minus of r minus 1 by 2. R minus 1 by 2 whole divided by 1 plus r plus 1 by 2 into r minus 1 by 2. R plus 1 by 2 into r minus 1 by 2. So now you see, by observing this series, This one will be in the form of this one is in the form of tan inverse of x minus this one is that x and this one is that y by 1 plus x into y. You know what is this formula? This formula you know that tan inverse x minus tan inverse y. So now you can write this value will be tan inverse of r plus 1 by 2 minus tan inverse of r minus 1 by 2. So this is nothing but simplification of general term. After that you have to find that sum of the infinite terms. Sum of the infinite terms means before I told you have to find that sum of the n terms. Sum of the n terms means you take that sigma to the general term. So sigma r is equals to 1 to n t suffix r. Now if you write that r is equals to 1, that gives the first term, r is equals to 2, that gives the second term, r is equals to 3, that gives the third term, and so on, r is equals to n, you will get nth term. So one by one all the terms, if you write it here, this one will be nothing but tan inverse of 3 by 2. R is equals to 1, if you write it, that is 3 by 2 minus tan inverse of tan inverse of this value is that 1 minus 1 by 2 is that 1 by 2. This is the first term, right? So now if you take that r is equals to 2, it becomes the tan inverse of 5 by 2 minus tan inverse of 3 by 2 minus tan inverse of 3 by 2. Okay, so next third term will be nothing but tan inverse of plus tan inverse of r is equals to 3, if you write that, that is 7 by 2 minus tan inverse of 5 by 2. So here finally you can write that plus finally this value will be, you see here and so on, it becomes that if you write that r is equals to n, that becomes that plus tan inverse of n plus 1 by 2 n plus 1 by 2 minus tan inverse of n minus 1 by 2 n minus 1 by 2. This is the last term. Okay, so now by observing this series, here you will be observe that plus tan inverse of 3 by 2 minus tan inverse of 3 by 2 plus tan inverse of 5 by 2 minus tan inverse of 5 by 2 and tan inverse of 7 by 2. Last term, this one will be cancelled. So what are the resultant values in this after the cancellation? So the last term, tan inverse of n plus 1 by 2 in first term minus tan inverse of 1 by 2. So the resultant value will be tan inverse of n plus 1 by 2 minus tan inverse of 1 by 2. Tan inverse of 1 by 2. Now here I want that sum of the infinite terms. Sum of the infinite terms means you write that sigma n is equals to sigma r is equals to 1 to infinity. This one is the tr. This one will get that by taking that limit n tends to infinity. N tends to infinity. Tan inverse of n plus 1 by 2 minus tan inverse of 1 by 2. So what is the meaning of this one? Here n is tending to infinity means n is only the variable, so that means remaining terms will be the constant. So if you replace n is equals to infinity, the first term will becomes that tan inverse of infinity. Tan inverse of infinity minus tan inverse of 1 by 2. So you know this value will be equals to how much? Tan inverse of infinity is that pi by 2 minus tan inverse of this value is that 1 by 2. So now you can write this value will be equals to pi by 2 minus you know tan inverse 1 by 2 will be equals to cot inverse of 2. So now according to one more basic formula, you know tan inverse of x plus cot inverse of x is equals to pi by 2. By using this formula, now you can write that pi by 2 minus cot inverse of x will be equals to, this value will be tan inverse of 2. So now you can see that options. What is the right option? This one will be equals to. So now you observe that what is that right option? So pi by 2 minus here all will be nothing but pi by 4 minus these values. So we will do one thing. According to the given options, you can take that pi by 4 plus cot inverse of x and pi by 4 plus cot inverse of x plus pi by 4 plus tan inverse of 3. One by one all the options you take it. First option you take that, option C you take it, that is the better. So option C and option D you verify pi by 4 plus cot inverse of 3. Pi by 4 plus cot inverse of 3. By option verification you can do that pi by 4 plus pi by 4 plus cot inverse of 3, cot inverse of 3. So now this value will be equals to pi by 4 value, you can write that tan inverse of 1. This is a tan inverse of 1. Cot inverse of 3, you can write that a tan inverse of this value will be 1 by 3. Tan inverse of 1 by 3. So you know this one is in the form of tan inverse x plus tan inverse of y. Now you can write that a tan inverse of x plus y. So 1 plus 1 by 3 whole divided by 1 minus x into y is that 1 by 3. This value will be equals to tan inverse of this value will be 4 by 3 is the numerator value. Denominator value is that 2 by 3. So now you can write this value will be tan inverse of LCM will be cancelled 4 by 2. 4 by 2 will be nothing but 2. So the result is equals to that above result. So here tan inverse of 2 you got in that above calculation, and after the option verification also you got it that for the option C pi by 4 plus cot inverse of 3 value will be tan inverse of 2. In case if this one is not coinciding, you should be verify that another option. So what is that right answer? Option C is the right answer. Option C is the right answer in this one. So here is that pi by 4 plus cot inverse of 3 is the right answer. Okay. Now in the same model, we will be discuss that one more question. See what is that another question to see. This another question will be this one. Now here this one will be tan inverse 1 by 3 plus tan inverse 1 by 7 plus tan inverse of 1 by 13. So very simple, you see here you can write that 3, you can write that 3 as 4 into r square minus this value will be 4 into r square. This value will be 4r square minus 1. 4r square minus 1. If you take that 4r square minus 1, you take that 4r square minus 1, you see here you can write that, or otherwise you can do it directly. Otherwise you can do it directly. So that will be tan inverse of, so 1 whole divided by, you can write that 1, you can write that 2 minus 1 whole divided by 1 plus 1 into 2 you can write it. Okay, plus tan inverse of 3 minus 2 whole divided by 1 plus 3 into 2. 1 plus 3 into 2. Tan inverse of 1 by 13 you can write that tan inverse of 4 minus 3 whole divided by 1 plus, this is that 3 into 4 you can write it, plus and so on. So by observing this value you can write that this one will be equals to general term What is that general term? By observing this one, TR is equals to tan inverse of n plus tan inverse of n plus 1 minus n whole divided by 1 plus n plus 1 into n. So this one will be nothing but, here you write it in place of n or you take it. So here in place of n you take that r. This is a general term. So you can write that r plus 1 minus r whole divided by 1 plus r into r plus 1. So now you can cross check this one is the correct or the wrong. If you write r is equals to 1, that is the tan inverse of 2 minus 1 by 1 plus 1 into 2. So that is the first term. R is equals to 2, you write the tan inverse of 3 minus 2 by 1 plus 2 into 3. That is the second term. So it is 100% this one is the correct general term. So now this expression is in the form of tan inverse of x minus y by 1 plus x into y. Now you can write this one is the tan inverse of x minus y. So this value will be tan inverse of r plus 1 minus a tan inverse of r. This is the tan inverse of r. So now in given question you have to find out that sum of the infinite terms. So every time I am telling you sum of infinite terms before you find the sum of the n terms. Sum of the n terms means what? To take that sigma r is equals to 1 to n t suffix r, right? If you write n is equals to 1, r is equals to 1, that is first term. R is equals to 2, second term. R is equals to 3, third term. And r is equals to n, if you write, that is the nth term. So 1 by 1, if you substitute r is equals to 1, if you write it, you can write that a tan inverse of 2 minus tan inverse of 1. This is the first term. This is the first term. Plus r is equals to 2, if you write it, tan inverse of 3 minus a tan inverse of 2. Tan inverse of 3 minus a tan inverse of 2. This is the second term, right? Next, r is equals to 3, if you write the tan inverse of 4 minus a tan inverse of 3. This is the third term. And so on, if you write that r is equals to n. If you write that r is equals to n. See, r is equals to n, if you write that, plus tan inverse of n plus 1 minus a tan inverse of 1 minus tan inverse of n. So this is nothing but nth term. Now by observing this all the terms, now you can find out that plus tan inverse of 2 and minus tan inverse of 2 will be cancelled. Tan inverse of 3 will cancel. Tan inverse of 4 will cancel. Like tan inverse of n will be cancelled. So what is the resultant value in this one? The remaining terms will be tan inverse of n plus 1 and minus a tan inverse of 1. So if you write in this value, that is equals to tan inverse of n plus 1, tan inverse of n plus 1 minus a tan inverse of 1 minus tan inverse of 1. So but you want that sum of the infinite terms. Sum of the infinite terms means what we discussed in the previous lectures. You take that sigma r is equals to 1 to infinity. Okay, TR will be equals to limit n tends to infinity. Now you take that remaining value tan inverse of n plus 1 minus a tan inverse of 1. You can write this value will be pi by 4. Okay, I hope everyone is clear this one. Now in this one, n is that variable. So put n is equals to infinity in that. It becomes a tan inverse of infinity plus 1 is the infinity. Tan inverse of infinity minus this is a pi by 4. tan inverse of infinity, that value will be equals to pi by 2. For what angle in tan? That will be infinity pi by 2 minus this is a pi by 4. You know, tan pi by 2 minus pi by 4, this value will be equals to pi by 4. So your right answer will be pi by 4 is the right answer. So all of you see that given options. Here in this one, you have that pi by 4 is the right answer. Pi by 4 is the right answer. So option A is the correct answer. This model problems mostly will ask in that mains examination or in advanced examination. So one more question we see in this model. Because of many of the questions we are discussing in this model, so please everyone is understand what is the importance of all these questions. So here you see, this is the next question. Question number 8. The sum of series cot inverse of 9 by 2 plus cot inverse of 33 by 4 plus cot inverse of 129 by 8 plus and so on to infinity. This one will be equals to what is that value? So now first of all you convert this one is in terms of this one is you convert in terms of tan. You know cot inverse of x value, you can write that tan inverse of 1 by x. So this value you can write that a tan inverse of this is a 2 by 9. Okay, plus and the next one is the tan inverse of this value will be 4 by 33. 4 by 33. Okay, plus tan inverse of 8 by 129. 8 by 129 plus and so on to infinity. So now you can observe that numerator value is the 2. 2 means 2 power 1. 4 will be 2 square. 8 will be the 2 cube. So the general term, the numerator value is the 2 power r. In denominator you see 9, you can write that 1 plus 8. 1 plus 8 will be nothing but this is that 8 you can write the 2 power 3. This one you can write that 1 plus 32. 33 you can write. 32 you can write 2 to the power of 5. Okay, and this one will be 128. So 1 plus 128, that is the 128 you can write that 2 to the power of 7. 2 to the power of 7. So here what is the general term of this one? TR is equals to tan inverse of TR is equals to tan inverse of 2 to the power of R whole divided by 1 plus, so 2 power 3, 2 power 5, 2 power 7 and so on means all the powers will be the odd. So you can write this value will be 2 to the power of R plus 1. This one will be 2 to the power of 2 into R plus 1. So this one will be nothing but general term of the given series. Now how can we write this one into the standard form? You see this one you can write that a tan inverse of, first you see that denominator value, how you can split that? This one is the 2 power 2r plus 1, you can write that r plus 1. So you can write that this value is the 2 power r into 2 power r plus 1. So numerator also you have to write in terms of that one. This one will be, you can write that 2 power r plus 1 minus 2 to the power of r. You can check this one. 2 power r plus 1, you can write 2 into 2 power r. 2 power r, if you take the common, 2 power r into 2 minus 1. So 2 minus 1 is that 1. So 2 power r you can write as 2 power r you can write as in this way. 2 power r you can write in this way. Okay, I hope everyone is clear how to write the numerator value. So after this one, this expression is the tan inverse of x minus y by 1 plus x into y. So what is that value? This one will be equals to tan inverse of x minus tan inverse of y. Tan inverse of 2 power r plus 1 minus tan inverse of 2 power r. Tan inverse of 2 to the power of r. So here this is the value. After you should be find first sum of the, here is the question is sum of infinite terms. So first you find the sum of the n terms. Sum of the n terms means sigma r is equals to 1 to n tr. Okay, now put r is equals to 1, that is the first term. What is the first term? Tan inverse of, this one is the 2 square minus tan inverse of 2. Tan inverse of 2, this is the first term, plus r is equals to 2. If you write that, that will be tan inverse of 2 power 3 minus tan inverse of 2 square. Tan inverse of 2 square plus the next third term will be, you write that r is equals to 3, that is the tan inverse of 2 power 4 minus tan inverse of 2 power 3. Tan inverse of 2 power 3, right? And if you write that 4 5 6, last term will be r is equals to n. If you write in that, you will be get that tan inverse of 2 power n plus 1 minus tan inverse of 2 power n. Tan inverse of 2 power n. So this one is the last term. Now by observing this sum of all these terms, plus tan inverse of 2 square minus tan inverse of 2 square cancel, plus tan inverse of 2 cube minus tan inverse of 2 cube, tan inverse of 2 power 4 and tan inverse of 2 power n. These terms will be cancelled. What are the remaining terms in this one? The last one tan inverse of 2 power n plus 1. In the first one minus tan inverse of 2. These are the remaining terms after cancellation. So this one here you can write that tan inverse of 2 power n plus 1 minus tan inverse of 2 minus tan inverse of 2. Now you see very clearly, you want that sum of the infinite terms. So sigma r is equals to 1 to infinity tr is equals to, take that limit n tends to infinity, tan inverse of 2 power n plus 1 minus tan inverse of 2 minus tan inverse of 2. Here n is that variable. So n is variable means put n is equals to infinity. 2 power infinity will be nothing but infinity. So this value will be tan inverse of infinity minus tan inverse of 2. Okay, tan inverse of infinity will be what? Pi by 2. So this value will be pi by 2 minus tan inverse of 2. So now this value will be, by using that formula, tan inverse x plus tan inverse y is equals to, what is that formula we know? That is the tan inverse of x plus tan inverse cot inverse of x is equals to pi by 2. So by using this formula, so pi by 2 minus tan inverse of x, we can write that cot inverse of x. So x value is that how much? 2. So this value will be equals to cot inverse of 2. So this is the your final answer. So now once you check that given options, is it the correct option or anything is you require the modifications? So please you say cot inverse of 2 is the correct answer. Cot inverse of 2 is the correct answer. So option A is the correct answer. Here option A is the correct answer. So next you see one more question in this model. All of you see this one. Same model question, same as it is. So please try yourself. So this one is that, try this problem. So if you don't get it, I will be discuss in the next video. Thank you for watching this video. Please like, share and subscribe the channel.